Okay, geometric shapes. In this video, we're going to give you lots of information about different geometric shapes, starting with triangles, moving on to quadrilaterals, and then doing some of the more regular shapes at the end. I want you to present the information that I give you back in any format that you choose. You could just make notes, you could create a PowerPoint presentation, you could make your own video and send it back to me. Up to you how you present it. I just need to know that you have actually learnt the information which is within. Okay, this is an equilateral triangle. Please remember that all of its sides are equal and that all of its angles are equal. Inside every triangle we have got 180 degrees, which means that if we split that by 3 in an equilateral triangle, each angle is worth 60 degrees. This is a right angled triangle. Again, it has 180 degrees in its internal angles. What distinguishes it is that it has one of those angles which is 90 degrees. That 90 degree angle is normally marked with a square at the bottom corner. This is an isosceles triangle. Please make sure you spell it properly. So it's I-S-O-C-E-L-E-S. It means that it has two sides that are equal in length and it has two angles that are equal in size as well. Our final triangle is a scalene triangle, and inside a scalene, no sides and no angles are equal, but the internal angles will still add up to 180 degrees. Moving on to quadrilaterals. A quadrilateral is any four-sided shape that has two dimensions. The angles inside any four-sided shape will always add up to 360 degrees. But inside a standard quadrilateral, there are no elements in common. So the sides do not have to be equal, the angles do not have to be equal, it doesn't have to have a right angle, it simply has to have four sides. A square is a specific quadrilateral. It's got four sides and they are all equal. It also has four equal angles, and those four equal angles will all be 90 degrees each, because 90 multiplied by 4 will give you 360 degrees, which is what the internal angles on any quadrilateral will add up to. A rectangle is next. This also has four equal angles. They are still all 90 degrees, but its sides are different. It has two pairs of equal parallel sides. The top are one pair of equal parallel sides, and the sides are the second pair of equal parallel sides. Those sides are not the same length, so you have two pairs of equal opposite parallel sides. Okay, the best way to think about a rhombus is as a pushed over square. That means that all of its sides are equal. Its angles are not, though. It has got two pairs of equal angles. This top angle, those two angles are equal, and also the ones I've marked in blue, those two angles are equal. A rhombus does not have any 90 degree angles. All of its internal angles will still add up to 360 degrees. Okay, on a parallelogram, the best way to think about this is as a pushed over rectangle. Again, it has got two pairs of equal sides. This one and this one are equal, and this one and this one are equal. A parallelogram does not have any lines of symmetry, and that's a key distinguishing factor of that particular shape. So no lines of symmetry, two equal opposite pairs of parallel sides, and its angles are not 90 degrees. Those two angles are a matching pair, and these two angles are a matching pair, but none of them are 90 degrees. The angles will add up to 360 degrees internally because it's a quadrilateral, but you haven't got any that are square. This is a trapezoid, otherwise it's sometimes known as a trapezium. It looks a little bit like the roof of a house in the way that a normal toddler would draw one. The key factor about a trapezium is that it has one pair of equal sides. They're here. There's a pair of equal sides on this particular example. It has got parallel sides, and the set of parallel sides are here and here. They're parallel, but they're not equal. It has its internal angles will add up to 360 degrees, but this particular example doesn't have any right angles in it. You can also have a trapezium, which is a right angle trapezium, which would look a little bit like this. Your right angle is down here. It has got one pair of parallel sides, they are here, but these sides are not equal. So your distinguishing factor on a trapezium is one pair of parallel, unequal parallel sides.